This is probably the last technical session, I believe, before I hand over to YB to have a closing. And I hope that I'll change a little bit the format of the style of my presentation here. Probably I won't start with a Gangnam style because I don't know personally. But I will definitely love to be here to be the privilege invited by Dr. Bernard, because being born in Penang and to be able to step back to this land and to share my regional experiences with everyone is definitely a high privilege. And today I actually wanted to go into a topic a little bit micro, but it actually touches on area where for example, Steve has covered the embryo system, as well as the different technologies that the different presenter has introduced, from the structural to the construction part of it. I'll probably end up to look into the perspective, like if you're going to do it right first time, how are we going to target on these specific items, and what are the key criteria of success to make it right first time. So let me introduce myself. You can call me Raymond. If you have any question, I don't think we have time. Unfortunately, we're going to take it offline. And I'm going to start with a little bit highlight of the technology where we have covered from the entire morning generally. We can actually look at the perspective of the changes of technology, because like my company, X4, is actually expertise in fiber optic. It's a Canadian-based company which has over 27 years of experience in the area of test and measurement. So what we actually have learned through the downtime of 2001 when the telecom bubble crashed is that our company very focused into the innovation, and we actually spotted FTTX being one of the early adoption at the time in the US, Verizon, AT&T. We participated from there, accumulated a lot of experiences. And until like 5 years back, I actually was working with Dr. Bernard in developing a so-called test standards, the criteria to help Telecom Malaysia in that perspective of getting the job done first time right. And if you look at, in terms of the technology where we actually come from, there's a bit of evolution that takes place for those who is already the, very experienced in the area of fiber optic. We actually go from point to point A connect to point B. But what the FTTX actually bring to the mass and bring to all the users, and we call this access, is basically point to multi-point applications. And at this point here is actually reference document from the council, is that there is a splitter to allow one light being shared by multiple users. And inside this single fibers architecture, we have to get it right, because these are the key different small enhancement, so-called, inside the technology itself is enabling so much of applications are being delivered to the users. You can see from here, in a single fiber, we have 3 wavelength, practically is a channels, if you like to call it. Like in Astro, you switch to 1 channel, actually deliver you the content. In this case, we have a maximum of 3 channels, but 1 channel is the user request to the network. And then the other channel is that the network deliver the content in whatever means of services. It can be HD quality services. It can be high-speed data, and even social media that is getting very common nowadays. And of course, the other rate channel here, 1550, is by means of analog TV. And in one of the good examples that we as a Malaysian is having a very easy adoption because of entertainment through the satellite provider. And having that, to have this kind of services is great, but when it comes to the turbulence of the weathers, sometimes we have difficulties. And if imagine that we have a very stable transmission media fiber, this would not be a headache at all. And if you look at the different flavor, as Steve has mentioned in his last slide, perhaps FTTX. So what is this X stand for? In most of the time, even today, we actually had the title being FTTH in a way. And H is actually stand for the house, fiber to the home in a way. And we also have other flavor depending on the choices of adoption you want to go into. For example, there is already a lot of couples in building. And in this process of brownfield conversion, we can see that very easy for us to pull a fiber to a node, we call it FTTN, or to a cabinet FTTC, and then we can leverage on the in-building cabling Well, don't ask me, and how old is the cable? Does it really still perform? That's another story, right? It's a choices that you can have a deployment strategy here, as well as to pull the fiber to the building, whereas I'll share with you in this aspect, this is where we go into another aspect of a multi-dwelling unit. Fiber is being put to the building, the basement of the building, and then being distributed accordingly to each and every of the floor, and in fact to each and every of the household. So you can imagine when we have fibers, it's all about speed, it's all about bandwidth, and it's about less interference as compared to the copper that we have got in the past. So why do I mention this fundamental FTTX where most of you have perhaps done your homework already? Because these differences in the technology change is making so-called the standardizations of the quality of the network deployed critical. And I'll go into a different kind of test best practices shortly to revisit all this area. And some of the area that you probably want to have a look is that from where the central office is, usually we have this feeder fiber to go into the distribution. So the distribution is where one split to many takes place. And in this point to multi-point deployment here, the fiber can even go to a building to further distribute up to the individual household. And when FTTH is concerned, is connected to the house itself. And we have different challenges as well, because as more and more fiber reach out to the general public, the challenges becoming like, how are you going to ensure that the fiber laid is good enough to last for many, many years to come? And one of the early experience that we had from town copper is none other than initial installation was good, but over time it get deteriorated, all right? And the quality degraded as well, to the extent that, well, if you look at the a number of blocks and everything, sometimes the complaint can be quite brutal to the operator, despite it has nothing to do with them. It's about when the infrastructure is exposed. There's a lot of vandalism, weathers, and we had such a high humidity with a raining season and dry season that comes in and out as well. So, and having to really look through the entire ecosystem of how to get it right first time, and really, to get the best out of it, we actually can divide the process of certifications, if you like to call it, or verifications, if you like to, in the different stages. It can go from constructions, activations, troubleshooting, monitor. This is where the network just in the greenfield environment being brought up. In a brownfield, they can put the fibers, and to the extent you integrate to the existing copper. And in all the cases that you see here, where we actually refer to in terms of the standards, of course, we have a look at the different perspective from constructions and the civil part. But on the actual technology per se, there is two organizations that is heading the standard. One is the ITUT group, so anything with the G.983 or something, they actually are driven by the International Telecommunication Unions, whereas the other school actually are backed by IEEE. Both are very prominent standards body, where you can see how deep they actually define in terms of choices of technology by means of GPON, by means of EPON. In the next generation PON, where we already started 5 years back until today, the late adopter, like we were talking to, for example, in Philippines, Indonesia, and even Australia, they are even trying to jump into 10G PON or 10GE PON as well. So it is literally just higher speed, more bandwidth, right? And you can see that the challenges for this is the distance. As compared to copper, there's a huge improvement of 5 kilometers. First, every time you want to call to get a streamix, for example, no operator preferred here, they will ask you, give me your phone number, because they're going to check how far you're away from their exchange. And now, with the fiber, you actually can go literally further away, 4 times further. And of course, you look at all the split ratio here. One of the things that relates to what Expo is doing is this parameter here. The first one is basically the ORL, so optical return loss. It is just representing a characteristic of how the fiber react when it is being deployed. And In terms of the challenges that we actually seen from the many regional exposure to the different operator, whether it is a new or existing or super experienced, you can see that mainly the challenges come from a loss of fibers and also tons of test results to manage when you are deploying some sort of verification to see that this contractor A, does it do the job right first time compared to contractor B, what is the performance of the two. The other aspect is that when there is a fault happening on that infrastructure, what is the mean time to repair for the different contractors or vendors? So, and out of all the challenges, of course, expertise is the area which is really precious, but most of the time is very hard to get. Imagine that you employ a lot of great experienced technicians, but they have very new knowledge about fiber optic. They turn their knowledge from copper to fiber. So these are the challenges that we see. So in terms of the solution, it is very important to ensure that we meet each and every of the challenges accordingly, automate it to give as simple as a pass-fail, and to get the things moving, especially when the network is growing tremendously. We want to spend less time in the office, but to get more customers to us, and by having a good quality of line that has been tested and deployed. So a case study in North America, and in fact we have done it in Malaysia, is pretty similar as well. And you can see that the best effort of deployment most of the time is no testing or verification. Roll it out and go home, okay? That's the fastest way. The other aspect is quality delivery, because fiber optic is very delicate media in terms of each and every of the interconnection. It can goes from basic cleaning to documentations of the fiber when it's first rolled out. When there's a problem, we can do a benchmarking to really see how good we are as compared to a year ago deployment. So the benchmarking will allow us to know if there's any deterioration, nothing to do with the operator. It can be due to the environmental factor, as I mentioned, weathers, and all sort of possible vandalism as well. So in short, of course, it is easier to do the best effort, roll out and walk away. All right, and in fact, the comparison model has done, in fact, we have a lot more data behind that, is the cost of not testing is far exceeding the cost of doing right first time. Because simply assume that everything is right on day one is going to be a big mistake, especially when you have to send a truck roll or send the people back to restore it when it is later on discovered to have problems within that fiber that has been installed. And in fact, you can see that here, well, Expo is not a Superman. The reason I chosen this one is so happened that this year is really a tough year for us. And in our sales meeting, we actually use this to really motivate everyone. When the tough gets going, the going gets tough. And for us, FTTH challenge here, we know. Because we have done so many few outside plant kind of testing and verification, if you have been, seeing in the region, you probably know which this logo is. And plenty of preparations before we go to the site. All right, what we actually do when coming to so-called verifications, testing, and pick the bone of the job quality of the contractor, not to say that we really want to, to let them have the delay or default payment, but in a way that we help them to get a quality network up first time right. And over a long duration of time, the headache that come back to them, in fact, is a very, very minimum. And it's actually a win-win situation. And of course, usually I do like a model, go up to the pole, but in fact I do nothing because I have no authority to touch the pole there. But what we actually do there is that, the access site that goes up to the field can be on the pole. It can be on the cabinet, and it can be on the a manhole as well. And these are the different area of deployment where we see in most of the time. When after we have completed the installation or so-called construction, it's always important to get to the point where we want to do a few identification. Later on, I'll share with you a very few common problems that's encountered in the real life experience. And of course, having to be able to do this in Malaysia, started in Malaysia 5 years back, and then go regionally to share with everyone else, including this morning I was talking to a New Zealand counterpart on their FTTX deployment. This is really a high privilege. So it's a bit confidential, but generally what we actually do here is from the central office through the true level hospital, we actually deploy a certain test tool, which I don't want to go to the product, but verification allows us to have the visibility of the quality of the fiber that has been deployed. And this is the summary of what I just mentioned in terms of the rising challenges from massive deployment. Suddenly, we got a project and we have to roll out, let's say, 100,000 of home pass overnight. And of course, inconsistent competency comes from there are certain, of course, a leader, supervisor that has been promoted also to become a manager that become less and less hands-on. Whereas he has to train the new people, you know, to start take up the role. So some of the workmanship qualities proven, the other one is very new, you know, that kind of inconsistency, and especially when we want to send everyone for training, but do we have the budget, do we have the training? Perhaps we should talk to the PTC in this aspect as well for the training. And to get everyone in terms of their expertise to go up is a challenge as well. So how do we actually overcome all these challenges? And of course, to avoid the pitfall is that we always assume when I plug the fiber into it, it is already super broadband, everything works fine. This is the first thing that we have to avoid, and also to have done all the testing already in the lab, and assume that this lab, when deployed to the field, are identical, will be a very you have to pay the price at the end of the day. So the control environment, known technician, everything's are there versus the actual deployment are significantly different. Of course, I should have used a micro trenching technology. There could be a little bit less civil work there. And you can see that we don't know what is next. And invest in today generally is to deploy a healthy network and be future-proof once again. So again, I couldn't remember how many times I mentioned get the thing done first time right. And this is the process where we can actually put everything together. And of course, these are the 4 common problems that I like to share with you from the personal experience. We have a group of people that is doing this as well. They are being trained. And the first one is actually connectors. And the second part is basically the macro banding. And the third one is the total link loss budget and ORL. And fourth one is the identification of the fibers. So for example, we can see that here. In terms of the connectors there, all right, sorry for the voice, but I just want to give you an idea how a typical scenario we can actually work on specifically hands-on with the fibers by means of proper cleaning. So this is a fibers, this is a wet cleaning tool, we could have a dry cleaning tool, and these are some of the fiber inspection probe that allow us to monitor up to 400 times magnification, and having this platform here to do a certification of pass and fail. So very often we see that this kind of process of certification, we can use a human eye to judge it is right or wrong, but we can even let the standards do the talking. And of course, when we encounter a fail result there, so a proper cleaning process kicks in. And this cleaning is highly recommended. In fact, if you go to the site often enough, you see that people do cleaning, but the creativity is unimaginable. Some is using a T-shirt, some is using a toilet paper. I'm doing a cleaning, you know, to do the job. But in fact, fiber optic is so delicate that, you know, a proper process to clean is so critical. And in fact, in the cleaning process, you can pinch, point down to like you don't. It is a dirty, clean. Dirty, clean. You don't do like dirty, clean, and do like this. Dirty, dirty, very dirty. So you don't know where you're getting yourself to. So, and of course, after a simple process and educational like this is probably the fun part to share with you. And we have a lot more details about each and every other individual item. Because of time constraint, I probably will pass them for now. And I need to get to the slide where it is not. So, and you can see that here. These are some of the best practices that we have got accumulated over years and I'd like to share with you. The first one is the dirty connectors. And to do the inspection using the fiber inspection probe first and do the dry cleaning and also the wet cleaning depending on the condition of the fiber. And of course, there are many rules of thumb associated to it, how we handle it, and that are the details that we can get off separately. So from the US, we learned something from them. Very quickly, we adopt it and we use it globally. And we are still pitching today the process called ICIC. Well, it's not a police that see you run a red light, ICIC. It is more than that, you know. It is basically the inspect, all right, to see that it is good or not. If it is dirty, we clean that. And then we inspect again. If it is all right, then we only connect them, okay? The other aspect of the challenges is about how do we actually manipulate the fibers. If we run it through, in a high-end condominiums, for example, or bungalow, you don't want people to drill a house without permissions or without communicating to you their idea. And of course, in that cases, you can see that most of the time, a lot of proper workmanship is required. And of course, unlike copper, we can do stapling. We don't recommend such in fibers, right? So if you do this, then of course, it's going to create what we call as a high fiber optic loss. The higher the losses, the weaker the signal. And at the end, we're going to suffer with a lot of problems. So the other method that we commonly see and has been deployed as a standard kind of in Telecom Malaysia and in fact globally per se, where Expo has reached in up to 2,000 of customers globally and also covering 80 countries globally. You can see that whoever that is doing, whether it's point-to-point or in this case a point-to-multi-point deployment, they actually have a peace of mind, like less than 10 seconds, one push of the button to get IL and OL tested. After tested, we quickly compare to the standard. If you are a GPON, this ITUT reference you can actually refer to. If you are EPON, you can refer quickly to the IEEE. So you have choices there. The other higher end of the instrument out there, we call this OTDR. So OTDR is a tool that is basically a must-have kit for us in most of the fiber optic maintenance team, because first of all, it's about the direction, how we actually test it and measure it. Secondly is that from the traces that we actually discover, you can see that there's a huge drop happening inside the trace. The drop means that it has a high losses. The losses is referring to the splitter that we are working with. A poor workmanship of losses can actually bring this graph further down. So of course, straight away we can tell there is a huge drop in the network, and we can tell exactly what location it is associated to. So then we can dispatch someone to rectify and fix the fault right away, having the right tool to identify such event. And in the newer generations where Expo is concerned, we have No8, conventional OTDR, and we understand so much so that the argument whereby in order for people to understand the OTDR, to read the traces and to work with it, there are certain training circles required. We reduce that gap. We introduce this innovation by putting in the iconized, very humanized iconized base, just like our smartphone is available today, and put it into picture. And I'll give you more information along that shortly. So the other aspect is that when the network is up and running, we really want to see that the service is running on optimum level. How do we know that? Because we are dealing with fiber optic. What is inside the fiber optic is light, all right? So if the light is strong, that means that we are receiving good signal. If the light is weak, we are receiving weak signal. This process is putting in place between the network to get the maximum out of the network. And of course, the other challenges we see in the deployment is because we are dealing with so many fibers out there. At times, the labeling are wear and tear. The labeling can be just misplaced, one with another. So a proper identification process would kick in, whereby we first need to get the right fiber identified before we go to next installing and connecting to the household or the subscribers. So this is where I want to mention a few things about what's new, because it is always good to share with you what is already available in the market, but also on top of that, what is the additional innovation you may find which is this word here, IOLM. So it's Intelligence OTDR, I like to call it, or Intelligent Optical Link Mapper. That's what it stands for. What it does is that a standard OTDR conventionally is going to give you this, and if you have a right, there's certain thing you can't see. With the point optimized OTDR, we see it end to end. That's quite basic stuff. With the point optimized OTDR as well, we need to undergo a certain process of training, of understanding the terminology, how to read it, how to interpret it. But today, you don't have to do that already. Put aside the training time, keep the budget to do more network expansion and get it done. We call it improve the time to cache. And you can see here as well, this is the icon that shows a pretty self-explanatory. It's a 1x8 splitter. They are cascaded. And here it goes with the connectors, and this is a splice. So these are all the jointing to allow us to deploy the fibers end-to-end from the central office down to the user side. So the concept of this is that it's basically running the same process using a smart algorithm. And the algorithm is using the multiple pulses within the OTDR, send a short one, medium, and long one, and we get the full details in summary. So, and the link-aware technology is so great that it allows us to automatically launches multiple acquisition at a push of the button, and also to consolidate the result. You see that this is a red for fail, green for pass. You can't get it wrong, okay? And of course, provide the complete optical link view with the icons, and it actually speed up the whole process of getting the job done first time right. And if you really take a look in one of the events here, for example, there is even a diagnostics goes with the test result. It means that we no longer have to stay with, we don't have to call our super technicians to ask him what's wrong, okay? Because behind each and every of these IOM, the expert go with the technician, irregardless of your age, irregardless of your experiences in deploying the FTTH network, okay? So, and the other aspect that we'd like to share with you also, you can see here, there are many areas of so-called verification point inside the network. We can get the thing done right. And this is another part where we can test from inside the house to look at the different perspective. Because don't forget, to have a fiber optic is a bless, but in addition, what kind of quality of experience you are getting out of it, right? And we can look into the perspective of the speed test, like what Stephen showed you, the speed test. You can actually do it from your house, having the right tool to do that. And you can even do the VoIP test as well. Beside the IPTV, if the HD content comes to you, you can even challenge by, during the harsh weather, to put the IPTV in measure to get the best out of it. So all in all, this is the whole picture that I have for you. And probably the last slide, where the time allowed me, is that when we come to the mesh deployment, there will be plenty of equipment out there. For information, we supply more than 1,000 of such units just for Telecom Malaysia for a 1.1 million home pass subscriber. Imagine that in Indonesia, the number officially I get on top of my mind is 50 million, and the first year is 7 million, all right? And the number varies from one country to another, but it is, getting the home pass ready. So there will be a massive of data that we are dealing with, and Expo probably is the first vendor that come up with the idea to integrate quickly to the very emerging trend of the cloud network services. So we actually today are able to offer a concept called Expo Connect. All the devices of Expo can upload the data automatically to the cloud server, which is secure and accessible by a certain administrator and even different group of contractor. Besides that, when there is time for all the unit of the product to be upgraded, we can actually push down the software to each and individual of them rather than recalling. The conventional way is out, the bandwidth is there, and the cloud network services is there. We are leveraging on all of these the pluses, and we maximize the usage of it. So this is probably the part that I have with you. And the last thing that I'd like to share with you is this. If you go to the Google one of the day this week, when you're free, you can just type Expo FTTH Pond Guide. What I just shared with you is just a tip of the iceberg. I didn't really go down into the deep detail to look at the values, what if we got this, what if we got that, right? And if you can access to this FTTH Pond Guide, it will give you a whole perspective dimension by looking at the technology, the standard of measurements, all in a one handy pocket guide that you can put in your pocket wherever you're traveling to. So feel free, and in fact we had a booth at the back there with our great partners, Kumpulan ABEX, that you can actually go and check out some of the happenings, that the innovation I share with you outside the booth. I think with that, probably is what I want to end my session with. Right, thanks.